in the lab in which I'm working as a postdoc researcher, which is Dr. Christina Schelz's lab, we really believe that the crosstalk between the B cells, mutated B cells, and the microenvironment is very important for the disease itself. So what we are basically doing is to study the interaction of these B cells, mutated B cells, with the surrounding cells of the microenvironment. Specifically in the lab I'm working on recreated CLL microenvironment in vitro, and to do this we are using a benchtop 3D bioprinter. So briefly, I'm describing now the bioprinting strategy, which consists first in collecting the leukemic cells. Then we mix these cells with the bioink, which is a kind of a smart material made of alginate or gelatin that is specifically designed to support cellular movements and function, as well as high printability. So then we define the structure that we want to print, and finally we are ready to bioprint the cells that will be like trapped in our gel. Then the cells will be placed in static or dynamic condition for the growth. So in the last year in all the lab we worked very hard to set up all the protocols for the analysis, so we can analyze cells viability, we can do flow cytometry, imaging, Western blot, real-time PCR, and finally also drug treatment. So there are not many papers in literature talking about 3D bioprinting. In CLL we are like the first group working on this topic. And we believe it's very important because what is the biggest challenge for studying CLL is to recreate a system that is closer to the physiological in vivo settings. So we think that the switching from the traditional two-dimensional culture is what we need to better study the native microenvironment disease and all the cells interactions. So it's not just about CLL cells, but also stromal cells like lymph node, fibroblast, or endothelial cells, and everything that happens between their crosstalk. Now we set up all the protocols, which has been very, very hard because, as I said, it's something very, very new. And what we want to do is especially mixing more cell types at once. We already starting doing that to recreate the exact microenvironment, and then probably to put this, most likely to put these scaffolds in a more complex system, three-dimensional system, which is, for now, we are thinking about dynamic growth in a bioreactor in order to better mimic the physiological settings. So briefly, the bioreactor is a structure, is a machine with a peristaltic pump. So there are chambers connected by channels, and where the cells can be can move inside. So we would like to recreate a kind of multi-organ systems with these techniques.